Hey guys, this is Coach Brian going over the 1.2 notes, and I'll be going over the 1.2 practice also. This is in case you missed anything in class, or if you missed a day of school, or if you just felt like you need some extra study or some extra help. These are to follow along. So I'm going to be going kind of quick through these, but you can always pause, rewind, re-listen, slow down, all of that kind of stuff. Again, this is just to give you a quick overview in case you missed anything in class or actually missed school. So to start off with, all of these things will be following along with the notes from Schoology through Canvas. You can also open those and follow along with the video as you go. But let's go ahead and get started. 1.2 is all about measuring segments, all right? All about measuring segments. And so a segment, if you remember from last class, is just a part of a line that has two endpoints and it has a finite length, meaning you can actually measure it. And that's what we're going to be talking about today when we're talking about distance. It is the absolute value of the length between 2 points. Absolute value of the length between 2 points. You can kind of scratch this out. That's an error. How do you find the distance? Use the distance formula. This is also in your notes, but the distance formula is the square root of 2 points. You would take the x of the second point and subtract the x of the first point. Whatever that difference is, you would square, and then you would add that to the y of the second point minus the y of the first point squared. And that comes from the Pythagorean theorem, which is how to find the hypotenuse of a right triangle. If you remember that from old math classes, a squared plus b squared equals c squared. This is what the distance formula comes from. And so it says, using the number line provided, find the distance of the following. So the first one we're looking for is B to C. And if you look, this number line starts at 0, but it goes up to 2, then 4, down to -2, down to -4. So each one of these marks is not 1. Okay, each large mark, all right, each large mark is actually, sorry, text box popped up in my way and I don't want that, so I'm going to delete that. Each one of these is 1, and each one of these little ones is 0.5. And so every time you go up a mark, you actually go up 0.5 instead of going up 1. But anyway, the first thing we're looking for is the distance between B and C. And we're going to be looking for how far each of them is from 0. So from 0 to C is 0.5, okay? And from 0 to B is -0.5. But if we go back to our definition, all right, if we go back up to our definition, it's the absolute value. And if you remember, absolute values are when you put these bars around the outside, and it's never going to give you a positive, or excuse me, it's never going to give you a negative answer. It's always going to be positive. So if we take our 0 to C, okay, 0 to C, and we take that 0.5, and we take our 0 to B, and it's 0.5, and we add those together, we get 1. And so we would say that from 0 to C, or excuse me, B to C is 1.0. And it doesn't really tell us what it's measured in, so we could just say units. So you would do the same thing. I'll do one more with you, and then I'm going to jump ahead here, but it says find DA. So we'd be going from this point over here at D, and from 0 to point D is 3.0. because it's 2, 2.5, 3. And then from 0 to A is actually -4. And then remember, we're doing absolute values. So D to A, 4 plus 3 equals 7 units. I'll let you do those next couple on your own. I'm going to jump ahead here. If I swipe, it keeps writing, so I'm going to try to stop doing that. All right, what does between mean? It says write the definition in your own words, so I'm going to let you do that. Between, for our definitions, all right, between means to be in the middle area of points. Middle area of 2 points. So you could reference this by where you sit in class, where our classroom is located, your house is maybe between the school and your work, stuff like that. But in geometry, we're going to talk a lot about this concept of betweenness. And this is on slide 8, if you're following along on the Canva. But betweenness has a rule. It says if points A, B, and C are collinear, that means you have 3 points. Sorry, my lines aren't super straight here. But if you have A, B, and C, and they're all on a line, then B is between A and C if, and this comes from the slides, if AB is less than AC and, all right, these both have to be true, and BC is less than AC. So what that's saying is this segment right here, A to B, has to be shorter than A to C. And so you can see right here, that's true. And then also B to C has to be shorter than A to C, which is also true. Moving on to 9, we have the segment addition postulate, and it's kind of all in the name. You have segments, you add them together, and if you remember from last class, a postulate is something we accept as true. So the segment addition postulate states that a part of something plus a part equals a whole. And what that means in here, going back to kind of this example, is if we took AB and added BC, all right, A to B and B to C, then we would get A to C. If we took these two segments, A to B and B to C, and we add those together, we get AC. Now you can see right here, is B perfectly in the middle? Okay, 1 second. No, it's not perfectly in the middle. It doesn't have to be perfectly in the middle to be in between. In this situation, it's a little bit closer, a lot a bit closer to A than it is to C. And that's okay because it's still between them. All right, moving on. We are now looking at measurement of segments. You've got some example problems here, and what I really want to point out is this section that says, that was darker than I wanted it to be, that's okay. It says, can you draw a picture? And can you label it? Anytime you're reading a word problem in here, you should be labeling what you're reading. For example, this says B is between A and C. So if I just drew that right now, I have A all the way to C. And guess what? B is between them somewhere. We just defined what between means. But also C is between B and D. So I actually have this fourth point, all right, point D, and C right here is between B and D, but B is between A and C. So you have to get good at reading these and illustrating what it is that you're reading. Now, it does give us some more information here. It says that A to B right here is 24 units. B to C is 11. Let me rewrite that. And C to D is 15. So then the final thing, and this is another skill, is what is a question actually asking me? And what it's actually asking me is to find the distance from D to B. And if you look, that would go from here to here. It ignores this section. I'm not worried about that right now. So I've got 11 and 15, and I would add those together, and I would get 26. All right. Example 6, a little bit tougher. It says M is between N and O. So I've got M right here, in between N and O. Find NO. So it wants to know this whole distance, which it's got a little formula right here for it, a little equation, 5x plus 2. NO equals 5x plus 2. But that doesn't help me too much because I don't know what x equals. And so I can actually set this up to solve for x with these other pieces of information I've got right here. These two segments, this one and this one, add up to this. How do I know that? Because a part plus a part equals the whole thing. So I can actually set this up as an equation, all right, 17 plus 3x minus 5 equals 5x plus 2. And so what I want to do is really quickly on each side combine like terms. So the 17 and the negative 5 combine to 12. And then what I want to do is actually solve for x. So I'm going to move the 3x over. I'm going to subtract 3x from both sides. So that will cancel out, and that will leave me with 2x. And then I'm going to actually move this 2 over. And so I get 2x equals 10. Divide both sides by 2, x equals 5. Did the problem ask me for x equals? No, it said to find NO. But to find NO, I had to find x first. So this is what NO equals, 5x plus 2. I would plug the 5 in for the x. That would be 5 times 5, which is 25, plus 2 equals 27. That's my final answer. All right, midpoint. Midpoint. It is all in the name. It is the point in the middle. That's what the midpoint is. It's directly in the middle, and it makes congruent parts. Congruent means equal or same. So right now, M is the midpoint of UT. And so that means u to m plus u to t equals ut. Made one error right there. Sorry. Let me say that over again. U to m plus m to t equals ut. Moving on, segment bisector. Again, it's in the name. Segment bisect means cuts a segment into two equal halves. Cuts a segment into two equal halves. So if I'm looking at this example right here, all right, I've got a line, that's too thin. I've got a line L. I've got a segment RS, and then I've got a point right there in the middle, point M. And so when I'm looking, a segment bisector means that a segment is getting cut in half. So in this case, my segment is RS. And it's being cut in half by this line right here, line L. And where are they crossing? Where are they intersecting? Where are they bisecting? They're bisecting at this point in the middle, M. Line G is a segment bisector, and it intersects EF at point D. So G, line G, is a segment bisector. It intersects a segment EF at point D. It says from E to D, so from E to D, that segment right there, that equals 4x plus 6. And DF from here to here is 7x minus 9. And it asked me to find EF, the whole length of the segment. So I have these two parts and I want to find the whole thing. So what I do is I take the two parts and I add them together. And so I want to combine like terms. And so I combine like terms with my x's. So 4x plus 7x is 11x. And then I have 6 and a negative 9. So 6 plus negative actually leaves me with that. And 11x minus 3 is the length of EF. Sometimes you can only get so far. And so 11x minus 3 is my length of EF, and it's my final answer. I'll really quickly do 8 and 9, but I would like you to try to do these on your own. It says M is the midpoint of segment RT. So I've got RT, and right in the middle, I've got M, the midpoint. R to M is 3x minus 2, and R to T, okay, so the whole thing, R to T, all the way to the end, is 7x minus 12. And so I'm looking for MT. Now, one thing that is key to know about midpoints is they divide a segment or a line or whatever, but in this case a segment, in half. So that means not only is this side 3x minus 2. It also means this side is 3x minus 2. But can we get an actual answer? And we can. We know that these two parts are m, which is 3x minus 2, and mt, which is 3x minus 2, equal r to t, which is 7x minus 12. And so I'm going to write over this one a little bit, over this way. So what I would do is I would combine like terms, 6x minus 4, and I would set it equal to this equation, 7x minus 12. And then what I would do, I'd like to take the smaller x value and move it over to the larger one. So I would take 6x from both sides. 7x minus 6x is just x. And then over here, I would add 12 to both sides. And I would get 8 equals x. And again, that's good to know, but is it what the question's asking me? The question is saying, find MT. MT, gonna move over here real quick. MT equals 3x minus 2. And I just said that x equals 8. So 3 times 8 is 24, minus 2 is 22. MT equals 22. And I know that that's a big giant mess, but there's my answer. That is all for the notes. If you're able to work 16 on your own, that would be awesome. If you missed, please try to make these up soon so that you can catch up with us. And once you're ready, move on to the 1.2 practice.